Hello, welcome to today's class. Today we would be talking about the reflecting surfaces. Now the most common reflecting surfaces that people talk about is either mirror image or water image. Let's understand why we use water image or mirror image as a phrase. Now reflecting surface can be in any plane. It can be vertical, it can be horizontal. So I have put in two diagrams here. This is a reflecting surface which is vertical, and this is a reflecting surface which is horizontal. Now the most common example of a horizontal surface would be water, where you can see a reflection, and a most common example of a vertical reflecting surface would be a mirror, where you can see yourself. So therefore there is a common terminology which says this as a mirror image and this as a water image. However, to make it very clear, it's not just the water, but if I say if a mirror is kept on a horizontal plane, it would create the same effect as the water would do. So it's very important to understand that we would be talking or we would be understanding reflecting surfaces in two planes. One is vertical plane and the other is horizontal plane. Now whenever we talk about image formation in a mirror, the most important thing is the size of the image and the size of the object would remain the same. Since it's a plane mirror, the size of the image and the size of the object would remain same. For example, if I am looking into a mirror, my image in the mirror would be of the same height as I am. Okay. Now, when the mirror is vertical, and this is what is the axis. Let me mark it as left and right. Okay. So what would happen is, when I am looking into a mirror, my top would remain top in the mirror, my bottom would remain bottom in the mirror. So if I have my head here, my head would be at the same position here, and say my legs here. So my legs would be at the same position here. So whatever is on the top would remain on the top, and whatever is at the bottom would remain at the bottom in a mirror image. But when I say left to right, whatever is closest to the mirror would appear closest in the mirror. So if I say, if I am standing in a mirror, my nose is closest to the mirror. So in the mirror, the first thing that I would see is, or the closest object would be my nose again. So if I say, I'll just rub this left and right to avoid confusion. Okay, so if I say there is a circle here, okay, this circle in the mirror would appear closest here, okay, and then there is a line here. This line would appear at the distant location here when I see the image in the mirror. So in a vertical plane, so what we would be talking here is a vertical plane. So in a vertical plane, what is happening is the top remains the top, the bottom remains the bottom. The object that is closest to the mirror would appear closest in the mirror. The object which is farthest from the mirror would appear farthest in the mirror. This is when we try to apply it onto a vertical plane. Now let's talk about the horizontal plane. So in the horizontal plane, what is happening is the things change along the top down. So what is happening here would be the circle which is closest here would again be closest here. As we can see, the reflecting surface, what is closest remains the closest, so the closest circle would remain the closest, and the line which is farthest would remain the farthest in the horizontal mirror or a water surface. So I can say this is an example of horizontal plane or any horizontal reflecting surface. Okay, but here what is important to understand is, what is at the left would remain at the left, and what is at the right would remain at the right. there would be no change in the position on left and right, but since you have rotated this reflecting surface to 90 degrees, everything which is along this axis would rotate. So the closest object would be the closest object here, and the farthest object would be the farthest object here. So I can say in a water image or in a horizontal reflecting plane, what is happening is the things are changing along the top bottom axis, not along the left right axis. The things that are towards the left would remain towards the left. The things that are towards the right would remain towards the right. So this is a very fundamental concept that we need to understand while we talk about reflecting surfaces. In most of the books you will find A to Z written, and then you would be asked to learn them by rote. So this would happen in case of mirror, and this would happen in case of water, and when you would be appearing for examination, it would be all mismatched into your brain. So what is important to understand the concept here? So this is the first concept that we are talking about in water image and mirror image. Now the next concept is excess of symmetry. What does the word excess of symmetry means? So excess of symmetry means anything that is similar along that line. For example, if I draw a square, okay, so let's say I am drawing this square, okay, and I am cutting this along the horizontal line. So the top half and the bottom half are exactly the same. So this is what is known as the axis of symmetry when it is horizontal, or in case of horizontal reflecting surface. In case of vertical, what would happen is, say if there is a triangle, I can say along this line the triangle are symmetrical. So this is exactly a replica of this. So this would be the axis of symmetry for vertical planes. Now axis of symmetry should be parallel to the reflecting surface. So that is the key concept. The axis of symmetry should be parallel to the reflecting surface. Now we will see how this happens with a simple example. So here is a mirror, okay. I have a letter H here, okay. Now the axis of symmetry for this H is this. So what would happen is, if I see the closest object, this line would be the closest object. Then I would have this, and again this line which is the farthest would be here. So I have an edge here. So this edge exactly looks what it is here when the reflecting surface is vertical. Now let's talk about a reflecting surface which is horizontal. So in a horizontal surface, what would happen is, if I have C here, this is the axis of symmetry which is parallel to this axis. This C would be exactly the same. So this C would start here and this would go here. So this would be a exactly symmetrical object that you can see in the mirror. Now if I want to draw any letter, say for example N, in the mirror, what would happen? So you have a mirror here, and I have a letter N here. So what would happen? This line which is closest to the mirror would remain the closest. This line which is farthest from the mirror would remain the farthest. Now this point from where the line starts should be closest. So this would be the point from where the line would start, and this point where the line would be ending would be the farthest point. So this point will be the farthest point. So this line would go like this. So this would be a mirror image, or the image of N when there is a vertical reflecting surface. Okay. Now let's move on to some examples of symmetry in case of vertical reflecting surface. So I am taking vertical reflecting surface as a mirror here. So if this is an image of a face, okay, you have two circles here. You have nose which is totally symmetrical and mouth which is symmetrical. This half and this half are symmetrical along this axis. So along this vertical axis, this side and this side is symmetrical. Similarly, these are the letters which are symmetrical in case of vertical mirror or a vertical reflecting surface. So you have A which is symmetrical along its vertical axis, H, I, M, O, T, U, V, W, X and Y. So these all letters are symmetrical. Now it's important to understand in case of Y. If I write Y in this fashion, it is symmetrical. But if I write Y in this fashion, it won't be symmetrical along the axis. So the mirror image won't be identical. For all these letters, the mirror image would be identical. So if you have T here, and in the mirror if you want to see the image of T, it would again be T. For this Y, this holds true, not for this Y. So for this Y, what would happen is, the closest point would remain the closest, the farthest point would remain the farthest. So this line would go like this, and this line would start from here and go outwards. So this would be the image of Y in the mirror. But if this is this Y, it is totally symmetrical along the axis, and since it is symmetrical, it would be identical in the mirror, and the mirror image of this Y would be exactly the same. Now we will be solving some of the questions based on mirror image. So the first thing we would be covering for examples is the mirror image. Now in this question I have to see the mirror image here. So as I mentioned, the top remains the top, the bottom remains the bottom. So this arrow should be towards the upside and this would remain on the downside. So this cannot be the answer. So I am removing choice B here. Now there are two extra dots here. So that cannot be again a choice. The three dots are here, but what would happen is the closest dot would remain the closest, the farthest dot would remain the farthest, and this one would be again here. And here what is happening is the direction is changing. It's kind of inverting top bottom, which is not the case in vertical reflecting surface as we have already discussed. So this cannot be the answer. So the only correct choice here can be D. So this point would remain the closest point for the start of triangle, and this triangle would form in this fashion. So you will have this triangle in this fashion. The next example here is, you have an arrow which is crossed by a line. So what is happening is, when I am talking about this arrow, you have the reflecting surface which is here. So the closest things become closest. So this should go into this direction, and then there would be arrow on this side. Okay. Now all these three meet this criteria except this. So D cannot be the choice. Now we will have to look out at the direction of the line. So what is happening here is, this line, this point would be closest here. So it would start here, and this point would be the farthest corner. So the line would go in this fashion. Now in which of these cases the line is going in this fashion, I can say it's A. Because here it's going down and here again it's going down. So the only choice can be A. So the correct answer for this question, the mirror image would be A. This is very interesting. Now when we are talking about letters, we have already talked about individual letters. Now when we talk about words, what happens is, if there is a mirror here, the E would become the closest because E is closest to the mirror. Okay, and this would move in this way, So the most important thing here to understand is the first letter would be E. Now, in all these four choices, we can say first letter is E. So none of the choice I can remove on that basis. Now some of the shapes will remain as such, like H and A. So H and A would remain the same. So H, A are again the same. E is inverted in all these. Now R, what would become is, the closest point would be this. It would go this way. Then this would be the closest point and this would be R. Now here it's a straight R, so this cannot be the choice. Here again it's a straight R, so this cannot be the choice. So what would be the choice here would be S, that we have to see, because A and H would remain the same. So S, this is the closest point. So what would become S? It would be this. So the closest point here would become the closest point here. The farthest point here would become the farthest point here. So the only option that meets this is D. So the correct answer would be D. Next, we have already talked about examples of vertical reflecting surfaces in case of figures and in case of alphabets and words. Now let's move on to clock. If I say in a mirror image the time is 8:35, what would have been the original time? For example, there is a clock, I am putting it in front of the mirror and the time that I can see in the mirror is 8:35. So the question asks, what is the original time? So it's very interesting kind of question. So what I would do here is, I would draw vertical reflecting surface here for that surface here. So what would happen is, this would go farthest and this would go the closest. So this would be the point here, and again this would go the farthest and this would be the closest point. So it would go this way. So the time, the original time is 3:25. But in the mirror what I am seeing is 8:35. So these are some of the examples that we have discussed about mirror image or a vertical reflecting surface. Now let's move on to the horizontal reflecting surface. This is one of the very good diagrams that I like to explain while talking about horizontal reflecting surfaces. So what is happening here is, this is a dog who is assumed to stand on the surface of water. So this is the surface of water, say. So the left remains the left and the right remains the right. Whatever is closest to this water surface becomes the closest point here. And the whole image kind of gets upside down. So the dog would look something like this when it's on the surface of the water. So this is a classic example of horizontal reflecting surface. Now let's try to do some questions and some basics on water image. So when we talk about water image, as I have previously mentioned, the axis of symmetry would be horizontal. So if I have C here and I consider this as the horizontal reflecting surface, or I should say water, the axis of symmetry would be this. So whatever is here would become here. So C remains C in case of horizontal water surface. So you have the common letters that would remain identical in a horizontal reflecting surface, that would be C, D, E, H, I, K, O and X, because they are symmetrical along the horizontal plane. Now let's solve some of the questions based on horizontal reflecting surface or water image. So if this is a question that is given and I am asked about what would be the what would be the image in the horizontal reflecting surface, or what would be the water image of this diagram, what would be the correct answer would be, everything that is on the left would remain on the left and towards the right would remain on the right. So you have this diamonds towards the left and you have this squares towards the right. That is correct. Now the top would go the farthest here. So this circle will go the farthest. So all these four would again be the correct choice. Now based on what we can decide is a single thing, that is this square and the triangle that is formed in this square. So what would happen to this triangle? when I am trying to draw, just I am taking this triangle and I am trying to draw this triangle. This would be like this. The water image would be something like this, because this closest line would remain the closest. This point would be the farthest, and this would be kind of upside down. So, in which of the following I can see such diagram is just one. So, this would be the correct answer for the question. Now, next thing is, you have a triangle here. So, what would be the water image along this horizontal axis would be, this triangle would be the closest. So, you should have an empty triangle on the top. So, this choice and this choice have an empty triangle on the top. So, I will just ignore the remaining two choices. Now, what would happen is, what would be the direction of lines? So, the direction of lines should be this. So, here the direction of lines is this. The direction of lines again would be this, because this would change and this is closest. So, it would become in this manner. So, the line should be this way. Here they are vertical, so they will remain vertical. And here, what is closest here is this, and what is farthest here is this. So, these lines would go in this fashion. Further, the remotest triangle, the small triangle. So, the correct match forms is here. So, then D would be the correct choice. Now, next question, nuclear. So, again we have come on to an example of words. So, the word nuclear, what would be the water image? So, what is towards the left would remain left. So, N should be here only. So, the first choice which says R is incorrect, because this cannot be the case in water image or a horizontal reflecting surface. So, N should be here. Now, if this is the surface, what would be N here? Would be something like this, the closest point here and the farthest point away. So, this would be N, U would be this. Now, in what all cases you have N and U in the similar fashion as this, then C remains C as we have already seen, E remains E, A would invert, so this would be A. So, you have A in all three. Now, what we need to differentiate is just L. So, L, this line would be closest and this line would be farthest. So, this would be the correct answer. So, L here in this shape is in this choice. E would remain the same. So, this is the correct choice here. Now, the last question is again of a clock in a horizontal plane or a horizontal reflecting surface. So, here you have the reflecting surface. What is closest remains the closest here. So, this point which is closest would become the closest here, and then it would move towards the center. So, it would move towards the center. What is towards this would remain this, and it would be again dotted like this, and this would be, this point is farthest. So, this point would be the farthest point, and it would go in this fashion. So, the time of the clock would change in this manner in a case of horizontal reflecting surfaces. So, in today's class we have covered how do we solve problems related to reflecting surface. In the case the reflecting surface is vertical, the best example is mirror. In the case the reflecting surface is horizontal, the best example is water. So, we can say we have solved questions related to specifically mirror image and water image problems. In the next class, we will be covering the same topic with further examples. Till then, have a good day ahead. You can subscribe to Examrace channel for further updates.